Hello guys, welcome to eSpark Tech Academy. Today we will be going through some capacitor concepts. Already we have explained the charging and discharging methodology in previous lecture, and these are the expressions for that. And this is the simple RC series circuit from where we have derived these and this graph, and accordingly we have also gone through what is time constant, the R and C product, and the time taken by capacitor to reach 63.2% of its source voltage. Source voltage is nothing but a applied voltage to it. Time taken by capacitor to discharge to 37% of its initial voltage. These both are same, and accordingly we will calculate the time constant. And when capacitor is fully charged, we derived it by phi into tau. Tau is nothing but R into C for series RC circuit. Accordingly we have calculated that, and we have yesterday we have explained you the parallel plate capacitor. In previous lecture we have gone through parallel plate capacitor. Capacitors are of different types. They are spherical, cylindrical, and parallel plate capacitors. Types of capacitor. In all these types there will be two plates which are separated by a distance d, here you can see, and the area of that plate or that cylindrical surface or that conducting plates, that will be the area. The distance is the separation of that plates, and epsilon is nothing but the relative permittivity, or you can say absolute permittivity here, ABS permittivity, PVT, absolute permittivity, epsilon, absolute permittivity, and epsilon 0 8.854 into 10 raised to minus 12 farad per meter. This is the vacuum or air permittivity. Air or vacuum, you can say, free space. And epsilon r, it is nothing but relative permittivity of dielectric medium. Permittivity of dielectric medium. It will be calculated in examples as the absolute permittivity divided by permittivity of space, this of air, free space, or vacuum. Please note down this, already I have explained. Now I will be explaining you the series capacitor circuits with series equivalent for capacitor and parallel equivalent for capacitor. First we will draw the series circuit of capacitor. First we will go through series capacitors equivalent. What is this? When the capacitors are connected in series and a voltage is applied across it. Voltage, this is C1, this is C2 and this is C3. These are nothing but the capacitors. One thing many students make mistakes in exam is that the capacitor terminals are of equal length always, and voltage is positive and negative terminal will be having different lengths. Just take it into consideration because in exam mostly students make these mistakes. That's why I am telling you. Now in series capacitors, actually what happens is voltage gets divided actually, because here V1, V2, V3 and charges are equal, actually Q1, Q2 and Q3. Here Q equal to Q1, Q2 and Q3 in series capacitors, and voltage will be Vt equal to V1 plus V2 plus V3. You know this basic formula actually of capacitor. In this case, what will be C1? C1 will be nothing but Q divided by V1. C2 will be Q divided by V2 and C3 will be Q divided by V3. When you calculate the equivalents, you will get it as V1, V2, V3 as Q by C1 plus Q by C2 plus Q by C3. In this, it will be Q will be common, hence C1 plus C2 plus C3. It will be the voltage, and here in this case Q upon C. As you know, this Qt here will be Qt equal to Q1 equal to Q2 and Q3, means all the charges are common. Hence you can cancel these both and you will get the answer as Ct equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. It is nothing but series combination of capacitors. Just now I have derived it. Please go step by step what I have did. Just the series capacitors, the circuit of series capacitors, when applied a V voltage across it, the as capacitor charges, the voltage potentials will be developed across the capacitor, and as in series the Q will be common, the I will be flowing through it particular current, and that current will establish